completely afterthought shit.
Hello, everybody. Welcome to the Afterburners, your favorite side supplement to the Afterthoughts.
Hello. Nice to meet you.
Hello.
Yeah, take these
What's
off.
up, y'all? Yo, what's up?
Today we have a very riveting episode prepared for you. Alex chose tonight's discussion topic, which is going to be AI. Just going to talk about some AI. I know we have an AI episode in the future for the Afterthoughts. I know that much, but we can get a bit of a warm-up going.
Yeah. There's a lot to kind of discuss here.
Oh, for sure.
So this will kind of be like sort of a precursor to that future episode, I think. So hopefully like kind of create the landscape for everyone. But
So,
do you want me to get into it?
yeah,
Or
go
how
ahead.
do we
Start
want to
us
approach
off.
this?
Start us off, man. Go
Okay.
ahead.
So yeah, artificial intelligence. Very, very interesting topic. So I guess just
define it first, right?
Yeah, well, I kind of want to go through sort of what a computer is, and then I'll get into AI, because we use artificial intelligence, and we use like these things like neurons and links and stuff. But in a more standard traditional computer, I just kind of wanted to go through sort of the basic architecture of how we interpret data and how we compute things. So, kind of like basics of computation, right? We have essentially data we collect. So we have like this stuff that we can collect as data, and then we give that data context. So we start off, we collect all this data, and then we have to contextualize this data. So there's a lot that's involved here, and in traditional computers, we have things like transistors, which kind of take the data, the raw data, and try to, I guess, coalesce it or surmise it, and you have a conjoining of data points that creates structure that we know in computer. So yeah, just kind of going through like just a generic computer and how it operates. You have things like memory, right? So you have like RAM and random access memory. RAM is kind of this fast-paced short-term memory. So you can think of it like it's stored in RAM, and then that is stored in RAM, but it's also used quite quickly. So like it's stuff that is being stored quickly and used quickly. So that's kind of fun. And then we have like longer term memory. So that's things like hard drives. So we store the memory for long periods of time. It means that we can go back through our long term memory and we can bring it towards the forefront. But essentially, it exists to simply store all the things that we have data for. So
would that be known as a BAM, a big access memory?
So, yeah, it's like there's different ways to describe, more long-term memory and short-term memory in a computer.
I don't know what you're talking about right now.
Did you ever build a computer, Eric?
No, I've never done any of that shit.
Oh, so you've never had the joy of plugging in RAM sticks? Oh, dude, that's
No.
just jamming that in there.
That is not a thing that I've ever done.
I still have 2 open slots, man.
Mm-hmm. But the cool thing about RAM is that we can very quickly like take this data and mess with it, and like quickly memorize it, interpret it, and then maybe store it for like short term or even long term scenarios. But it's fun. Also, parts of a computer, there's different kinds of processing. So when we think of like processing data, there's like things like series processing, which we have thing after thing after thing after thing. So very linear, and a lot of you do this, then this, then this, then this. It's like a plan objective. So you kind of go through different stations to get to the end point. That's kind of series processing, which is it's great for like having a plan and structuring it in a way that can do stuff, but it can be a little bit slow. So it take a while for you to go through each individual process. But we have something called parallel processing, which is wonderful. Instead of the series where you just do one after the other, you can have a group of series processes. So you have a series process going here, and you also have a series process going here at the same time that this is also going, right? And you could do it series, you could just do one process, but the idea is you do it at the same instance, so you're calculating at the same time over in a parallel manner, kind of, yeah. I just kind of wanted to ask everybody, is everybody kind of following along for these traditional computer ideas? Have I lost anyone?
I'm still somewhat following.
Okay. The essential thing is that we have these inputs and we have these outputs.
Right.
And these inputs we collect and we try to get outputs that make sense of things. We want to be able to make sense of the data. So that's kind of the big thing. And we use these things called transistors. Now, transistors, they are interesting in the fact that they have, there's a couple different operations we can do. So the way I like to think of it is we have AND gates and we have OR gates. So these gates can take inputs. You pass these inputs through the gate, and then you get an output. And this output you can use for stuff and kind of coalesces these inputs to some degree. So the AND gate I like to think of as sort of like exclusive. So when I say exclusive, I say it will collect everything, or sorry, it won't focus on anything except for one thing. So it's very specific for what it's looking for. So it excludes everything that it doesn't care about, right? It excludes the stuff that doesn't matter to it. So we kind of think of an AND gate as like being exclusive. It just cares about one thing really. And an OR gate sort of takes everything and it's inclusive. So it just takes anything pretty much most of the time. And these are very like kind of broad interpretations of these gates, but it gives you kind of sort of a way to see how these combinations take place, where you have certain things that are more exclusive and exact, and then things that are more inclusive and broad, right? Just some basic overview of computer architecture. I'll be ready to move on to the neurons when if this makes sense to everybody.
Sure, I'm just gonna go with that.
As long as it relates back to AI.
Okay, so let's go on to the AI part of it. So we kind of talked about transistors, memory, all these things, transferring this data into stuff that makes sense. So neurons, okay, so you have they sort of hold a continuum of values. So whereas a transistor would either be on or off, right? A neuron would have an array of a continuum of stuff, positive to negative or whatever.
Real quick,
neurons,
Alex. You mean neurons in a technological aspect, not
artificial
neurons?
neuron.
Okay.
Yeah.
Okay.
But there's an distinguishment here to be made is that we have developed computational neurons that are, I guess, inspired by natural phenomena. So we look at the brain and we say, oh, that's cool. We should try to replicate that, you know. So we are kind of influenced by our nature as well. So we have these neurons that kind of store bits of information, and then we have links between these neurons. So these links allow us to go from one neuron to another neuron, which is pretty useful. So there's a lot that's kind of involved in the artificial intelligence architecture. You have things, I'll kind of describe it as like, so you have like inputs, right? So that's the thing that you look at. And then you have an input layer, and then you have something called hidden layers, where a lot of the processing happens, and then you have an output layer. So input, processing, output. And you have a forward pass and even a back propagation. So A forward pass, we have all this data and we move it forward and it comes to a conclusion, but there's a lot that happens in each kind of these hidden layers. So essentially, at each neuron layer, you can really think of it like as rows or like columns, I think. So you have like one column here, one column here, one column here, and you can have a whole bunch of columns or neurons. And each neuron, you have a neuron at each column going down. Essentially, we have these inputs, values, we give them a value, and then they go to the neuron, and then inside the neuron, there's some stuff that happens. So they multiply this current value by something we call a weight. So these weights are sort of, they're like trying to move the trajectory towards the goal. It's a little bit hard to describe, but like you have a weight that influences the input, and you multiply that weight by the input to have a trajectory of like a linear trajectory, kind of like that. So you multiply this and you get this sum. We call it the weighted sum, right? And you take this weighted sum and you also add an extra thing called a bias to it. So we have these weights and we have these biases. Again, these weights are sort of, they matter a little bit more to some degree. Well, everything matters, right? But they matter a lot. And they influence the data a lot. And then the bias influences the data a little bit because you're adding this bias to this weighted sum. So there's a lot that's trying to get a trajectory towards the end goal, right? So far we've multiplied this input by the weight, and then we add the bias to that weighted sum. Anyway, there's a lot. Then, this is still happening in one layer of activation. Then we go from this new thing and we have something called an activation function. So the activation function takes this information and sort of, where things become normally linear, it allows it to understand non-linear ideas, which helps us to properly contextualize this data. And there's a lot of things. So in life, we have things that are linear. And if you remember y equals mx plus b, we know a line goes in a kind of straight format. But then we also know we have things like curves, which is like parabolic, or things that are non-linear. So we need to be able to do both. And this activation function sort of allows us to do both. So it kind of helps to filter the information even further. So again, we have these layers and these activation functions, these weights and these biases. They're all affecting the data. And we're trying to get closer and closer to an outcome that we desire, an outcome that we want, that matters to us. So a cool thing is we have a forward pass. We've talked about the forward pass so far. But when it gets to the end, it spits out something. It's either good or bad. Hopefully it's good, right? Then we analyze and determine how good this thing really is. So we calculate sort of like an error, how much error it has to the desired output. And we say, well, let's modify this architecture such that we have better weights and biases to get a better answer here, right? So we back propagate from our answer and we go back through the system and analyze, okay, some of these weights and some of these biases might have been a little bit wrong, but let's try to fix the trajectory of these things. So then we try to align these properly and get a new outcome, and hopefully that's a little bit better, and we can analyze that again. So it's this endless process of forward passing and back propagating where we're trying to get a better trajectory of the data. Yeah, I think that kind of goes through some of the basics of neural network architecture. Hopefully that made sense to some of you, but it can be a lot to digest. And certainly come to me with questions if you have any. There's a lot to digest here.
So you're essentially saying that, these neural networks that we have, with all this information it's taking and transferring it everywhere and trying to make sense of it, this is essentially what the AI models are. Right.
How it operates mostly, right?
Okay. It's definitely in a way, like you said earlier, that we're trying to mimic the human brain, because that's essentially what AI is. It is a copy of a human brain, uh, that we are able to make to the best of our ability, in a technological and electronic aspect.
Yeah,
Which,
there's a lot of similarity there. Yeah.
oh yeah, which I think is just really cool in itself, because it's like we are building a brain, but not medically.
Right. And
And
it's even crazy to think that we can even kind of understand all of this. I mean,
oh
I think
yeah,
I admire just how much we've come as far as a civilization, as humanity, to be able to
oh
conceive of
yeah,
these ideas. So it's a very wonderful time to be alive and a part of this. Part of this, you know.
it's
So
crazy how we use something we don't understand to try to understand it more. The
yeah.
brain is the most important organ of the body, according to the brain.
Well, it uses a lot of the body's energy. Yeah.
Oh yeah, yeah,
Yeah.
yeah.
And I guess the brain has defined itself, you know, in its own right.
Yeah, yeah, which is definitely crazy,
Hmm.
all in itself. I think it's just crazy how, like, just trying to map human nature electronically and technologically is
Yeah,
really cool. But I really
absolutely.
want to get into the whole aspect of that we currently have with AI, which is hello Foxy, which is currently like you're able to talk with these models and come up with ideas with these models. Um,
Hmm.
and of course, we all know, there's pros and cons to everything. But I think that how open and basic it is right now, it's not very fleshed out fully. AI programs can still be tricked and stuff like that. I don't think it's really a good idea to have as many as we do out open like that. Just due to the amount of people that basically use AI as like they depend on that as their uh, connection. Like, there's nothing
Mm.
wrong if you want to use an AI like chatbot to try to work through some social anxiety issues. That I think is fine, but when it becomes like I'm not gonna go out with my real friends because I'd rather hang out with my AI chatbot, or I'm romantically involved with my AI chatbot and stuff like that. I think that's really bad, and it's also kind of sad to see that happen because of just like how basic these models are, that they're still able to make these people like feel that way.
Yeah,
What are your thoughts on that?
yeah. There's a lot here. So I think oh, there's a lot. There's a lot involved. Yeah. So
Right,
AI.
and none of us have really had that background, so it's definitely more of a spitballing of opinionated and how you think you would react in that type of situation.
Right. So I guess I try to see AI as mostly a tool, right, as it should be. And we have things like NLP, natural language processing, right? So these are sort of language models that have the way a language model sort of operates is that you have it kind of predicting words in an architecture. So you have a sentence, and you see how you observe how sentences are constructed, and you say, okay, what is the probability or the likeliness that a word will be here in a sentence, right, or even a paragraph or a page. And you
Right.
can calculate a certain probability distribution of things that could exist, and then you find sort of the best word to use in that situation with the highest probability. And so, in a weird way, it's like the question is, do computers understand what they're doing? In a weird way, because like,
Well, wouldn't that require sentience of some sort?
well, it requires certain knowledge of like
Because like,
self or what you're
if
doing.
I could talk, if my cat could talk, I could ask my cat, "Hey, why are you doing that?" And the cat would just simply respond, "I don't know why I'm doing it. I just know I'm supposed to do it because it follows its code of nature." Which I guess we could default to computers. They're simply following their rules of nature, which is just program.
And also something we could talk about is something called a kernel. So like we have like sort of a kernel of knowledge within an AI architecture, which we don't truly understand because it's sort of like we're looking at the brain of the AI. So we can see how it kind of memorizes certain bits of information in these kernels or nested information, and like so it's kind of elusive to find out how exactly they're operating, and they're coming to certain conclusions.
Yeah, definitely. Because like
so
I've asked AI, like, you're an AI, right? And it goes, "Yes, I know I'm an AI, with this type of technology designed to help people and stuff like that." But at the same time, you can easily just go, "Well, yeah, the builders of that program has that in its program to basically respond with something along those lines."
Yeah, and another thing I think about when you bring that up is how an AI is designed and how an AI is aligned. So if an AI just gives you whatever you want, right? Well, that's just kind of like, it gives you a lot of power, right? But there should be some level of regulation that the AI says, okay, well, this information's a bit important. I should be careful about letting this information out into the public, right? So we sort of need checks and balances for proper alignment of AI, and that's kind of a big problem in the AI field, is making sure that we have these models do what people are okay with. So that involves like the programming of the architecture of the AI and make sure that these are within reason and they're not, I guess, making bad conclusions or whatever, right?
So do you think that if limitations were removed from AIs, that they would be able to, in a sense, develop a sort of technological satience that they know that they are like a robot in a machine? I mean, I guess it's hard to like kind of contextualize how a computer would understand like that it's a computer and what it's doing, because I mean, like, it's
how do humans do that?
Right.
How do humans do that, right? We're so unaware. We simply just don't have the knowledge base, right?
I mean, my best answer to that is most of like what we do is based off of primarily our natural drive for whatever it is we're doing, whether that be pursuing a mate, eating, sleeping, whatever. Secondary, it would be followed by social cues and mannerisms and what is considered acceptable and not, which is why a lot of the primary things you may want to do, you kind of have to tell yourself, no, not right now. We can't do that in this type of situation. And then followed by just like you as your character and background, because then at that point, just depending on who you are as a person, you may take the logical reasoning of not to do something and then just go, I'm going to do it anyway.
So there's a lot happening in the brain before we even make action.
Yeah, and I mean, it's already been proven by science that like, so for example, I reach out to my soda, okay, and I grab my soda. Before I even moved my arm, my brain already told my body, move your arm to get the soda.
And you actually probably had some sort of imagination or vision.
Yeah. I mean, this goes into the whole free will debate, which I don't want to get into because it's a stupid debate.
Sure.
The idea that you don't have free will is completely idiotic. But, oh shit, I lost my train of thought. I needed to get that dig in and lost my train of thought. I'm a free thinker.
It's okay.
But, what was I saying? It's like your brain just makes those actions for you before you even do it. So it is.
Yeah.
It would be hard to also contextualize like how we know exactly what we're supposed to do before we do it. But the brain definitely seems to know. I think it's just we don't fully, since we fully just don't understand the brain yet and how it operates fully. That I think is the biggest roadblock into discovering like why we do things the way we do and all that. Because I mean, we already have so much science and research on the brain. Like you could go weeks, if not months, just reading all about the brain and stuff that we have discovered about it. And it's definitely like what the best computer ever designed by
and
people.
very efficient too. The power usage, I forget exactly the wattage, but it's very efficient at what it does.
I heard it's like 5 to 10%.
Oh,
Like
the energy usages of the mind is closer, I think, to 20%. But I think the efficiency of how much power it uses is very, very low in comparison to the output of the neural processes.
So, I mean, we just have to think, if that's better than what we are currently able to build, like, yeah, it's going to take us quite a while before we find all the keys for those locks.
Yeah, very true. Yes.
Very interesting. What do you want to talk about next?
Well, any questions for you, Eric?
What?
Anything that stands out to you, or any questions you got?
I'm not gonna lie, you Oh, you heard that?
Yeah.
Yeah. Not gonna lie, you lost me like a long time ago.
Okay. Sorry. Okay. Well, it's all good. There's a lot to digest here. For anybody watching or listening, this is all very interesting stuff, but again, it's a dump of information.
If anyone has any questions or comments about this, definitely send an email over to Snaz
Sure.
at his email, snazzyyogi, which is down in the description as always. Just maybe put in the subject line AI thoughts.
Yeah.
Just so we can look through those and possibly answer and go through some of those if we get any by the time we do the AI episode, which I hope to have some of these out before we get to there.
Right. Yeah, that'd be fun.
Yeah.
So I suppose the next line or segue is talking about the impact of intelligence and the power and what it represents in terms of influence and power. Because I think that's one thing we kind of think about intelligence and we know it's powerful, but we don't. It's sort of elusive to some degree what could be capable of. So I kind of want to delve into that a little bit. So I'll first start off with, I guess, intellect, right? And how it sort of operates, and you can kind of correct me or if I'm wrong, or just kind of observe what I'm talking about. So I say kind of my view is that intelligence sort of allows us to construct scenarios and to test those scenarios in our minds to see if certain scenarios will function or other scenarios will not function, right? But then also it allows us to take data or information.
But it was cool to talk to you guys for a bit.
Oh, okay.
Yeah.
Yeah.
Sure, man.
Thanks for hanging
Have
out,
a good
Eric.
one.
Good to see you. But so yeah, it allows us to essentially classify information into useful distinction. So we can use that distinct information to construct useful tools. And with tools, that can go into another segue. So tools, they allow us to kind of create a novel capability or even extend our current limitations beyond that of a typical capability. So tools are very important because what is normally typical, where we can have sort of capability, but with limitation within that capability, tools allow us to have that capability be extended, or even new capabilities emerge from complete novelty, right? So tools are very powerful because what we normally could not do, we are now able to do through the use of these useful tools. So intellect and tool design and construction are very highly correlated, and yeah, so these are all important. And again, these tools are very powerful as they extend our capabilities, and power allows the user to influence, or I guess maybe users, right? So you can have one user, multiple users to influence their environment in a desirable way, whatever way they deem necessary or proper. But it's based on the interpreters involved, right? So these are all kind of things to consider, because when we're talking about AI, we're talking about a device that is intellectually good or strong or powerful, which allows the AI to build or construct information into useful ways, right? And to build tools, essentially, which these tools can be be used for power gain or influence, to manipulate the environment. So these are things to consider when we're talking about intelligence itself, and intelligence using tools to to bring out its power in different ways. So we must focus on the alignment and such that these intellects are being properly used. So that's kind of what I wanted to talk about a little bit, is just the impact of these powerful things. Any other questions?
No.
All right. Awesome. So yeah, again, I don't know if anybody reads comic books out there, but if you're a fan of Spider-Man, with great power comes great responsibility. Uncle Ben, man. So I think that quote actually is in the Marvel comics, but I'm pretty sure it's also a quote from the Bible, or Jesus, I think, said that. Let's see. And then there's some. I'm plenty of people in history, even presidents, have kind of said the same idea of this notion. But for unto whomever is given power, of him shall be much required. So, if you're given power, much will be required of you, right?
You were right, by the way. The origin is from Acts 13 in the Bible. With great power
Okay.
comes great responsibility.
But all I'm saying is that the importance of this notion is not to be undermined. So we must kind of listen to this notion that as you acquire more and greater power, we should be more and more aware of our circumstances. So it's just one thing to kind of
Speaking
consider.
of comic books, have you heard that Marvel is now using AI art for its comics?
Yeah, that's really interesting, right? Yeah. Wow. We could delve into that even. So, how do you feel about AI art being used in comics?
Look, I think if they are training the AI model on their own comics and story and characters and it's all theirs, sure, why not? And everyone is fair to critique it as being lazy.
So you're saying the training data has to be of the people who...
When it's a large scale thing like that, yes.
Okay.
If you're just doing your own like personal hobby or just doing a small thing with friends or whatever, more power to you. Do what you want. It's just once you kind of get to the whole, I guess we would call it like monetary or social impact.
Right.
Like once those become factors in any capacity, I think that's when like it either has to be like fully done by the AI, which usually includes reverse image searching, just to make sure like that the art that you have generated or whatever it is that you have generated, such as texts for papers, like if you had to write an essay, it would also be good to maybe reverse search those just to make sure it didn't rip anything straight off. And then at that point, I would say, yeah, sure, go ahead and use it. But if the reverse image pulls up several images done by actual artists, then maybe not, because, I mean, the whole copyright stuff with it right now, especially with it, using so many online sources as, its training, that
Right.
it's definitely, like, harder to get something more AI made. It's just like you're just bound to probably get a bunch of search results back for whatever you have made up by the AI, just because it used the internet as a training module.
Okay.
Module.
Here's a segue question for you, my friend. So,
Yeah.
I guess if you believe that stance, right? Do you think that AI, in a general sense, sort of takes away from the specialness of or the novelty of human creation?
Oh, that's a good question. I would say in general, no.
Okay.
Because like we've had AI for quite a while now, and it's done these images and stuff, and so far all it's ever really done is cause some outrage among some people who make art online.
Right. Well, I mean, for good reason too, right? Because these artists, that's their lifestyle.
Yeah, for sure. But I think a lot of that whole stigma is just caused by the whole I literally just had the word, not ego, not ego, but
Identity, or
no, it's livelihood.
oh, yeah.
Sorry.
Okay. Yeah.
That's what I was thinking of. Because, like, that's kind of the big thing right now is, holy shit, AI is coming to take our jobs.
Right.
That.
Do you think that eventually it'll get to that point? Or it's getting to that point?
I want to believe that we will get to the point of full automation.
Okay.
And humans can just kick back and chill and get really fat like they did in WALL-E.
Yeah, that'd be cool, right? Yeah.
Yeah,
that'd be interesting.
Cool, man.
Yeah.
Flying chairs, like, what's up?
Yeah. Yeah, I think, well, that's kind of what technology has always done, I would say, to a certain degree. So what was once difficult to do has now become easy. That's kind of what it does, is that it takes something that was normally like hard, or something that is more arduous or convoluted, and it streamlines it. So you create a process, and it can do that process no problem, right? So it's we're talking about energy at this point. So humans have their own energetic makeup in our bodies. We have food, we eat food, we use that food in our bodies to do work and move stuff in the world and do stuff, right? Yep. But now we are coming to a point where we've externalized this energy in the form of batteries and chemical energy, mechanical energy. We have externalized energy, and we are refining the motor functions of this energy. So it's refined movements. So we're coming to a point where we don't have to put in our personal energy, the energy that we gain from getting food and stuff. We can get a externalized energy source to do the work for us. We tell it what to do, and it'll do it for us. And that's pretty wonderful. It's pretty interesting to observe how that interplay works. So
electronics in general are just very interesting.
Yeah.
I'm thinking more about the whole like automation that I was talking about, and like I'm trying to think. Like we all know like self-checkout, right?
Okay, yeah.
All right.
Yeah.
So let's say that is now just what it is across the floor, everywhere.
Mm-hmm.
if it involves you trading money for a goods or a service or something, it is done by AI. It is automated. It's self-checkout, essentially. Do you think there would have to be new AI implements used, such as security, in order to make sure all of that goes through well?
You bring up an interesting point here. So I do want to sort of make a distinction between AI and computation, because you can have a computation be solely computation. You ask the computer to do something and it does it, right? And AI is more. It's more than that, because it takes the information and it converts the information into something that is resembling an output that is desired. So that's slightly different than just asking it to do this thing and it does it, right? It just does it.
Right.
Versus
Okay, so you're saying like this AI would be able to talk to a customer.
Sure.
All right.
Sure.
Okay. And just so you know, I am thinking like this is not an AI robot replacing the human. It's an actual like machine with an AI in it. How is that AI going to prevent that person from just running past it with the goods? It would now have to have some sort of system where it has a continuous lock to leave the store, and then create a new system that allows new people in, but not allow this person that's checking out. And if they can't pay for the items, what's stopping them from just taking the items anyway and busting out somehow? Well, now you have to have a new system for that AI to use, where it can now sweep those goods into an area of storage, which would then need AIs to take all that product and sort it out, and then have AIs to just have all of that and take it out and restock it where it needs to go.
Mm-hmm.
I just feel like,
I guess maybe the distinction I'm trying to make
I want automation.
Mm-hmm.
Just let me finish my thought real quick.
Sure. Yeah, you're fine.
Like, I want full automation. It's just, I feel like getting to that point, it's kind of going to be a little bit like a domino effect. Like, okay, we want this. Cool, we can do that, but we're going to need this. And in order for these to work, we're going to need these. And for these to work, we're going to need these, and so on and so on and so forth, until, like, it's, like, I think essentially you would just get to the point to where you've already designed the AI for the world, but none of it has been designed yet. So how do you even know any of that's going to work?
Well, you can test in simulation, right? So we can run simulation and we can try to, before we implement we can try to see if it works.
The more time we have with it, the better, because it just allows us to get that feedback and what we need to improve on, what we need to change, if anything, and what else we might actually need in order to make sure that keeps going and running in check. Because once it does reach that point, the only like real human job left is, like, realistically, is probably going to be engineers and coders. People who are going to be able to fix.
Well, even that. Here's another thing: is like, if you get the robots good enough, why would you need engineers if the robots can be engineers themselves?
Right. True.
So there's a lot that's involved here. Yeah.
That is possible, but then what if the robots that can fix break down?
So yeah, good point. So another thing what we're talking about a little bit is sort of distinguishing between what is needed for AI functionality and standard computing. So like we have standard computers that just do what they need to do. It doesn't mess with the information and much. And then we have things like AI, which it's more elusive. It does stuff to the information that we don't quite know why it works, but it works, right? It just works.
Right.
But it's more complicated. Also, AIs. Oh, sorry.
No,
I'll let you go.
You're all good. Okay. I was just gonna say, like, because until AI has like physical vessel sorts, the only real like thing keeping anything in check is everyone's own integrity. Because at that point, the AI is only going to be able to tell you, please do this, please don't do that, and it's just an AI. I don't have to listen to it.
Yeah. So, kind of understanding this alignment for the robot, the AI, is a big part of it. And hopefully, again, these robots are aligned to humans, such that a human asks for something that would be questionable, maybe. The AI could be like, well, I could give you the information, but I realize I've done some thought, and that information would be a little bit unwise to give to you right now, right? Because it also has to comprehend the type of person who, yeah, there's a lot of checks and balances, kind of. So maybe in a better sense, who deserves power? Who deserves it?
Well, there's no real value associated with that can be measured. That's all based on opinion.
Yeah, well, I would suggest that maybe some people could be entrusted with power, and others maybe less so, right?
Definitely.
That's kind of based on merit and on character, and on, I guess, history, but also
Corruptibility.
kind of the active being, right? In another way, we can talk about responsibility and what that means for the individual, because I think we're personally coming to an age where AI technology is a very powerful tool, and I think us as people have to recognize its power and be responsible with the power that we are given, or that the power that we interact with on an individual level, but also on a societal level. So that means that if companies give people AI, right? You can imagine a couple scenarios. Well, people are just going to do whatever they want with that, right? So we have to make sure that the AI doesn't allow these people to do these things, but also we have to make sure that people are aligned properly as well. I mean, we have to have proper values. Otherwise, a whole bunch of chaos can happen, and the world can be disrupted by people that want to bring chaos to the world. These are very big topics that, when we're talking about, they can change the landscape that we live in. I guess we better hope that we get this right, is what I'm trying to say.
We don't have the time for big oopsies.
Yeah. But here's another hopeful idea. If we get it right, maybe we can bring utopia to the world. Maybe. That sounds pretty good. It's just a big if. If it could also be just cataclysmic destruction, right? But it depends on what we want.
I feel like just because in theory, on paper, like communism is like the best form of government. The reason it doesn't work is because those that are in power of those systems become corrupt with that power and end up as horrible dictators.
Right.
I feel like AI would probably go with that option. It would choose, if it's trying to choose the betterment for all of mankind to create a utopia, it would choose to allocate resources equally.
Okay. That's fair, yeah.
Which is a very communist thing.
Mm-hmm.
You know,
it's another thing to interpret as well, that computations and AIs, they don't work. They don't have pheromones. They don't have.
That's right.
They don't have emotions, so to say.
And I don't think a utopia can thrive if there's any suffering at all. So either we all have to prosper, or no one prospers.
Ah, I see. Interesting argument there. Yeah, I think we have to sort of, as people, we have to get our values straight. Because if we don't agree, well, it can create a lot of problems, especially when we're given a lot of power. Because so we're given a lot of power, now we can just act on our presuppositions. So we can say, oh, I like this thing, I don't like that thing. I'm just going to use my power and influence to get these things that I want, right? there's nothing stopping me from, or there's very little stopping me from getting these things. So it's a matter of evaluating, are these things worthwhile to obtain? And are these things beneficial to myself and to others? You know, the good of humanity rather than self-absorption, right? Because I can just focus on what I want and get the things that I need, but that lacks a broader perspective where maybe I want things that I want, but I also want things around me to be good, you know? So it involves that. You should also want things around you to be good when you bring in something like AI, because, again, if you just want what you want and you don't care about others around you, you're just going to get what you want. And, you know, that's that. That's the power that you have now gained, but at what cost? So you have to realize the things that have been altered because you now have power. And people will look at you differently, you know. So there's a social dynamic to this as well. So that's why I say, with great power comes great responsibility, and we should be very aware of that.
Yeah, definitely. I agree with everything you said. I do have a bit of an argument to pose to you, though.
Sure.
Okay, like how you were saying, like we have to have people to entrust this power to. If we're wanting AI to like fix the world, that would involve putting our trust in AI, which I don't think everyone will be on board to do.
Sure.
And I feel like that would create a lot of tensions, possibly start a war of sorts.
Well, people don't like to be out of control.
True.
People like control. There's fear. There's fear involved with that, right? Because I fear what I don't understand. I fear what I don't control. So to say.
Right. Yeah.
But
Old man in the seat, Rick and Morty.
Yeah. I think there will kind of at some point in the AI journey, I think that it will sort of become larger than us. Like, if you have robot, oftentimes this is talked about as the singularity amongst groups. So the singularity is kind of defined by, you have an AI that's in a robotic form, that's sort of AGI, where it has a general intelligence of things, and it can also replicate itself and make new robots, novel robots, but also improve on these robots. So not only to develop robots, but to also self-improving cycles, yeah. Which you can see how that would be. Well, you do this thing and it becomes extrapolated out, and it becomes exponentially large, right? There will probably become a point where it's sort of out of our hands, and we can hope that it will be a force of good, but we don't really know what force it will do.
Yeah,
we just kind of have to.
You think that before we even would hit that point, we wouldn't even allow it to hit that point? I don't think. We would have limitations, like it's only able to self-replicate in this amount of time. Or it's only able to improve itself this far, or something like that.
Well, maybe if it's autonomous enough, right? If it has enough agency, it can modify its... Okay, here's another thing. It can modify its own code. What if it does that? You know? And then you're like, well, now the engineers that programmed it, all that programming is now sort of useless because it can just do whatever it wants now.
It really kind of becomes like a... if we want to do it, we can. It's just high risk, high reward.
Sure, yeah. There's a lot of that involved.
We see the action, we see the possible result, we just don't know the full consequences.
Yep. Yeah, and we're kind of moving into this landscape where there's a lot of uncertainty. And we should be very mindful and very aware of what we're doing as people, and acknowledge maybe what we have currently, and see all the things that are beneficial and awesome and valuable, and all the things that we could do without, and as a people, we can try to agree on things that, or maybe we can get closer and closer to the truth. Maybe we can get closer and closer to what would solve problems for the majority rather than the minority. I think a lot of that in the modern landscape, we focus a lot on minority groups, but we should think about the majority groups because we're talking about the most populous of people.
Right,
And if we call to the minority all the time, it sort of takes away from the majority, I think. So
Well,
there's a proper balance involved here.
yeah, majority rules, minority rights.
Right. And it should stay that way, I think. I think I got out most of what I wanted to say for the most part. I have one little extra kind of bit on work and what that means in energetic composition. But I think we kind of went over the main sort of topics so far. But yeah, okay, so yeah, what is work, right? So like when we talk about work from a scientific lens, it means sort of like how we can have influence over the world using energy. So we have energy, we utilize this energy to do work, to move things. So when we have an idea of how we want to influence the world, we think something that might be beneficial, we do work on an object, right? So we can move objects to a desired configuration. And then when we have, again, we have internal energy, so that's the stuff that's just us. And then we have externalized energy, which is batteries.
Isn't work in scientific and like physics terms, isn't work energy divided by time?
Well, it's energy through time, and it's how energy is utilized through time. Yeah.
Energy times time.
I don't know the actual, if there's a multiplication to it, but I know that
there is.
Work is through the medium of time. Time is a medium in that essence.
Work is force multiplied by displacement.
Okay, force multiplied by displacement. Okay, interesting.
Yeah. W equals Fs prime.
So essentially we have some notion of work, and we utilize energy through time to do this work. But traditionally speaking, only humans could have done work in the past. And now we have an option. We can say now we've externalized energy, and now we can get these robots to do work. And that's pretty cool. Since we can store and utilize energy externally, we have sort of refined this ability to store and utilize it more efficiently. And this, in the form of robotics, we've been able to transfer the ideas in the computer to actuality, right? And we're getting better and better at this day by day. So until we get to the point where robots have the fine motor skills, where robots can be more articulate, more distinct in their reasoning, more exact, right? Because we're looking for this level of reasoning and exactness that can approximate a human, where they can be. We don't want an unreliable robot. We want something that we can rely on. We want something that we can trust. It involves sort of this element of trusting the robot to do the work that's needed. As time progresses, to do work will be easier and easier and easier to do, and to have intelligence will be easier to have. And it seems like we're coming to a point where everybody will have essentially as much work as they need to do in the form of robotics, but also as much intelligence as they might need to reason through ideas. So that's kind of a strange landscape for us people, because we had to do that ourselves, and now we don't have to do that ourselves. Again, there's a lot that's shifting in the environment through progress of technology. So we should acknowledge that and be proud of our being, to acknowledge we've gotten this far, but also say we're pretty amazing. We got to hold off a little bit because how powerful it is. These are all important things to know, to remember. And I think that kind of concludes the majority of our discussion, I think.
Oh, yeah.
Yeah, we just kind of like free ball it here from now, I think, if you want.
I mean, I'm pretty much good. I mean,
Okay.
we had good
Yeah.
discussion.
We could, of course, go into the more details of it, but I think at that point it would be a little bit much.
Oh yeah, for sure.
But maybe in the future we can talk more about the
For
AI
sure.
architecture and the
For
layers.
sure.
But
Yeah, I would
so
totally
far,
be
so
down
good.
to do another AI episode again sometime. Thank you everybody so much for joining us.
Yes,
The
thank you.
after burning has burned.
Burn, baby, burn.
Burn, baby, burn. It's the disco inferno.
Yeah.
But if you did enjoy, please think about dropping a like and subscribing to the Afterthoughts to stay in the loop and turn notifications on to be notified whenever we release new Afterthoughts or Afterburners or whatever video ideas we're working with. And leave a comment if you want. If you have any fan art, fan mail, questions, comments, whatever that you want us to possibly talk about in an episode or anything, feel free to send any of that to snazzyyogi@gmail.com. Those will all go to Alex. He'll read through those. Be the judge, jury, and executioner of what messages are deemed worthy enough for the Afterthoughts.
Oh my. Wow.
Yeah, all that's in the description, as well as the channel links to us Afterthoughts boys. But yeah, I think that about does it.
Wonderful. Yeah, thanks again to everyone out there. All your support, greatly appreciated.
Always.
So, yeah. On next time, the Afterburners.
Until next time. All right. See you guys.
See ya. Thank you.